I'm doing something kind of unusual today. I'm starting with the end in mind. This is where your homework is going to be. So I'm sort of showing you what I want to teach you. Like, you don't know how to do these yet. Now, you could be smart enough to remember how to solve this without any help. Okay, look at number 1. We did do this last year. Now, there's some coming that are totally new, like you could never do them without the instruction, but this one you might be able to do. Anybody have an idea? Yes?
Set the bases.
Set the bases equal. Now stop for a second, because yeah, you're right. But, yes?
You could rewrite it as a log, log base 2 of 8, which is also 3.
Okay, so you could rewrite it as a log. I like it. In the context of the logs unit, I like it. Anybody else have another idea? I know some of you are like, isn't 2 ideas good enough? Oh yeah, I know. But once again, stumped the class, and you could have just graphed both sides and see where they cross. Okay. How come you guys can't remember that? But I hope that me badgering you about that makes you remember that as an option. Because when you're on the ACT, nobody thinks of that either. You know what I mean? You can always graph it, see where they cross. It works. Okay, but anyway, so, and you will actually have a calculator, at least for part of the problems they were about to do here in this unit. All right. Like for we have a lab coming up called the M&M lab. I decided Friday's a good day for eating M&Ms. So, oh, somebody's going to be gone Friday, aren't they? Of course. It's no big deal. But it's in tomorrow, Friday, yes. So, this lab involves M&Ms, and therefore, of course, there are some kids that are like, I'm not eating M&Ms that somebody touched. I totally understand that, and if that's you, that's fine. But some of you are like, I'm not that discriminating. I will gladly eat them. Or you guys could just be careful about, like you dump them on a piece of paper. And some you might just get lucky and be paired with somebody who's like trying to lose weight, and then you get to eat all of them. Or you could just like only touch the ones that you're going to eat. You know what I mean? Like once you pour them from the cup onto the paper. Anyway, all right. The safest thing would be to just throw them away, and it's okay. But some of you guys might choose to eat them. And as long as you're really careful and sanitary with them, I'll be careful and sanitary with them, and they'll come right out of the bag. But all right. So I'm hoping you remembered that this whole 2 to the 4th is very similar to 2 to the 3rd. So now the bases are the same. So 4x equals 3. And then if you can't solve that, we get some problems. All right. So another option somebody gave was rewrite. Yes. Let's do that on number 2. Because you already got this answer pretty much done. Let's just divide by 4. And we got 3/4. George, what was that second way? Not the graph both sides way, but...
Rewrite it as a log.
So this would be log base, what?
3
of 27 is equal to x minus 1. And do you get that now I just have to add 1 to both sides and the x is alone? X will be alone as soon as you add 1 to both sides, right? Okay. Now, what is log base 3 of 27 though? If you rewrite the 27 as a 3 to the 3rd, then it's just 3. Okay. Now, wait. I want to show you another way. You can take a log on both sides of an equation, and it will also work. I'm going to give you a fairly simple one. 2 to the x is equal to 8. Would you agree that that answer would be x equals 3? Okay, so I'm not establishing this as like a super hard problem. I'm saying it's an easy one. Do you get that? Maybe you don't know this. Maybe this is a new thing for you. You can introduce a log onto both sides as long as you use the same base. And you might be thinking, why would you ever do that? If you choose your base strategically, in one fell swoop, you're done. What base should I choose? Somebody be smart. base 2, do you get then that x equals log base 2 of 8? See what I'm saying? And x is alone. By taking the log of both sides, since the bases are the same over here, that's just x. And x is alone. So you can take the log on both sides. That is called, if anybody asks you today, by now your parents are probably so jaded, they've asked you, what had happened at school today so many times, and you're like, nothing, that they probably have given up by now. But if they say, what happened at school today? You can say, I learned how to exponentiate. It'll be very impressive. That's called exponentiating. All right. And when you take the log on both sides, you turn the exponent into the answer. Exponentiating. All right. Okay. But what if it's more complicated, Mr. Server? Look at number 8. Everybody look at number 8. Can I still make the bases the same? Yeah, and that's kind of my thought, but what about that 9? What am I going to do with the 9? Make its base the same too. What is 9 actually? 3 squared. But then I'll have a 3 squared and a 3 to the 7x. Whatever would I do? Combine them and make it 3 to the, be careful now. Interesting. So you're saying that a squared times a to the 5th would be a to the 10th. Is that what you're saying? Okay. What is a squared times a to the 5th? Just like, I'm doing this off to the side. This is a good technique, by the way, if you're like, what's going on? Oh, yeah, this is the kind where you add them, isn't it? Yeah. So then this would be 3 to the 2 plus 7x, or 7x plus 2. Yes. All right. And then that 1/9, could that be written as a 3? Oh, yes, it could. That could be written as 3 to the -2. Good. You think of it as 2 steps. If you take a 3 and you say, how can I make it a 9? Just a 9. You'd say, oh, I'd square it. And then, how could I make it to the 1/9? Oh, yeah, the negative makes it flip. So that'd be -2. All right, so that would be 3 to the -2. Then be careful with parentheses. To the 2x. And then this other side was this. But we're going to simplify that to, I don't want to do the whole problem for you. I pretty much have, but you got to take it from there at least. Okay, but wait, Mr. Server, these are all different. They're all so weird. They're like, but I've given you 3 ways to do it. You could try rewriting it. You could try bringing in a log on both sides. Or you could try making the bases the same. Which way do you want to do this one? I don't care. What do you think? That one. What feels the most logical to you? Doing a log of base 1.005? That feels kind of like a weird base for a log. I could. How about a rewrite? Everybody, just for a second, prove that you know how to rewrite still, because it's the number one thing you had to know how to do in this unit, is rewrite things from exponents to logs or logs to exponents. Is this a log? No. Teal, can you make it a log?
Log base 1.00
Of
3
is
12x.
excellent. And is x close to being alone? Yeah. You just got one more step. Last step. Back row. Divided by 12. X is alone. Now some of you are like, but I couldn't get that one in my head. You're right. And it's okay. So nobody's going to expect you to know what log base 1.005 of 3 is. Now, I want you to get the distinction between giving me a decimal for this or giving me the exact answer. Some people feel like, oh, I'll use my calculator. That'll be very exact. No. Do you get calculators have to be rounded? Do you get my answer right now? Has not been rounded. So my answer is more exact. That would be the exact answer. A calculator answer would be a rounded answer and not exact. All right, enough about those. Looking at these. Are these different? Yes, this is why they're on a different page. So how do we treat them differently? Any ideas? A lot of smart kids in here. Two of them that are falling asleep, but they're wearing jackets, so I understand. They're getting too warm. It happens to me too. All right, so this, you know what, if you had a calculator, you could graph both sides, see where they cross. That's good. You can pretty much, anytime it's an equation, you can pull that one out. I'd like to find another way than that, because this one would be pretty gross to have to even graph. Like, that would take a long time. Hint. Do you like fractions? Most people don't like fractions. How about we get rid of them? So what could you do? Multiply both sides by e to the x plus 2. All right. Now, there's one more coming up that I need to get you ready for. And that has to do with, actually, I'm gonna go a little further with this one, just because like that doesn't just instantly solve it. We'll multiply both sides by e to the x plus 2. And then that'll cancel that. 100 e to the x is equal to 50 parentheses e to the x plus 2. You just distribute it out, and you'll have 100 e to the x equals 50 e to the x plus 100. And now I've got, it gets confusing just because you're not used to seeing e to the x's all over the place. But if that had just been like an n, do you get I just have variables on both sides? Just get rid of the smaller one, and it's not that bad. And then it'll turn into one of the problems from earlier where you'll either exponentiate, which means put logs on both sides, or you could graph both sides, see where they cross, or once you've subtracted 50 e to the x from both sides, you could try to make the bases the same, but that'd be difficult in this case. All right, this is probably a rewrite or an exponentiate. It'll be easier once you get the e to the x alone. So your next step is going to be, well, I'm going to ask a kid. I got 50 e to the x equals 100. What do you think we should do next? Divide by 50. Yep. Okay. Don't let negative powers freak you out. See how it says e to the negative 3t? Let's break that down. It's really e to the negative 3, and then there's another variable, but for one step at a time. What does e to the negative 3 mean? 1 over e to the third. Yup. And e, if it was just a number, oh, but it is. 2.718 approximately. It's on your calculator. Okay. That number cubed, if it's about 2.7, I'm going to round to 3. 3 cubed, it's about 27. So that's about 1/27. All right. And then there's a t. There's a power of t. It's like it's separated like this. Do you get what I'm saying? It says negative 3t. I know, but I separated it like that because that is all just number. That's a number. And then it's number being put to a power, and so it's still just a number. And it's a number to the power of t. So the real variable here is just the t. E is not a variable. Know what I mean? E is a number, 2.718. And so the only variable there is a t. So there's a variable in the power, that's an exponential, and then, ooh, I could make it into a log. All right. So today is just a lot of solving log questions. And there's one more at the very beginning that I want to explore for a moment with you. This is called odd solving. These can be odd. They can be strange. This does not mean like even versus odd. This means like weird solving. Okay. This one, not nice. Anybody have an idea besides graph both sides and see where they cross? By now, I don't even want to. I'll have George yelling that out if I don't say it. Is there any way to solve this? Any ideas besides graphing both sides, see where they cross? Yes? You are right. You set it equal to 0. So we're going to add 6 to both sides. Very nice. Now I know that doesn't just like insta solve it. Sure 5? Or did you just find it? Okay. That is rare to find money around the school. I think if anybody sees it, they just vacuum it up quickly. I got lucky the other day. I found a $20 bill laying in the grass next to a sign. There was nobody anywhere nearby. Fair game. Woo-hoo. My best ever, I was on a beach. $100 bill, folded up $100 bill in the sand. So, and I was really like kind of torn because there were people around. It was not like it fell out of this guy's pocket or I would have given it to him, right? But there was people around. But what do? Go like, whose $100 is this? You know what I mean? It'd be like, there'd probably be 3 people would say, mine. Yes. Oh my gosh. That's pretty. Now that is a new level of integrity. That's impressive. Okay. All right. So I betcha we're just going to ignore this for now. I said right off the bat, let's not use the graph both sides and see where they cross. Now, not using that though, is there any other thing that you can think of? Yes. If you can factor it, you should. You remembered. Now you're probably thinking, what do you mean? How do you factor that? Well, just try. You can. You can. Would you agree a 2 and a 3 would make a 6 and could make a 5? Aha, then what the heck goes in the front of this thing? Ah. Some people are confused at this point because they're like, how is that e to the 2x? If you times this, remind yourself off to the side and go, isn't that kind of like a to the second times a to the third? What would I do with those two? I would add them. Isn't x plus x equal to 2x? It works. Yes. And if you can factor it, you should. Didn't I say that would often solve the hardest problems in this class?
Yeah.
I did. And when people get stumped, I'm trying to say this not because of this class, but because of the rest of your life in math. A lot of times the key is, oh, it can factor. And as soon as it factors, boo, everything falls into place, things cancel, etc. Okay. So yay. Now what? So yay, it factored. So what? Yes? Yes, you have to solve for x. How? Okay, so e to the x plus 3 equals 0. And e to the x equals negative 2. E to the x equals negative 3. Now what? Rewrite, or this might be a good time to exponentiate. Do you even know what that means? Do you even exponentiate? Bro? I just ln'd both sides. What? Natural log, same as log base e, which means that x equals ln a negative 2. And you just said you can't do that. And I was thinking to myself, well, I just did. But now I know what you mean. Why can't you do that? Can't have a negative argument. So that does that mean that this whole process is flawed? No, that means there's no solution for that side. Could there still be a solution for this side? Well, maybe, but I'd try it and I'd go ln of e to the x, which would mean log base e, so that's just x, equals ln of negative 3. And no, that doesn't work either. So then there's no solution. What if I would have graphed both sides and saw where they crossed? Then there would have been a solution. No, there wouldn't have been. It wouldn't have crossed. There would have been two lines that wouldn't have crossed. All right. Yes. Sure, go ahead. Which part? Oh, the ln part. All right. At that moment, we had it down to, here, I'll take the ln's out. We had it down to this. Do you get that I can put a log in on both sides? Do you get I get to pick any log base that I want? So then I'm choosing log base e. But as soon as I do that, and I take log base e, this side just becomes x. That's the beauty of it, is it's solved for x. And this side becomes log base e of negative 2, and you can't do that because you can't have a negative in the argument, and therefore there's no solution to that. Here is another way to say this. Ask yourself, how am I going to take 3, put it to a power, and get the answer to come out negative? You can't. So there's no solution. Okay. Odd solving, part 2. How do you solve that? These are the oddballs. Do we sometimes put them on tests? Yes, we do. So pay attention. Not saying these are on the test, just saying just because it's odd or unusual doesn't mean you don't know have to know how to do it. I'm trying to add flexibility to your life a little bit. All right. Could you graph both sides and see where they cross? Yes, but where they cross wouldn't be the answer. Okay, wait, what does that mean? Here's where they cross. Y equals 8. Y equals 2 to the x. Do you get that they would cross? But the point is, when is this bigger than, i.e. above 8? When is 2 to the x above 8? Right there. From that moment on, and x is 3, and 3 doesn't work though, right? Because 2 to the 8 is, it would be 8, and 8 isn't bigger than 8, so 3 doesn't work, but it's from 3 to infinity with a parenthesis like that. Seeing the picture helps. So I encourage you to make a picture when you're stuck on something like this. Because you'll see the picture and you go, oh, when is this above that? And then, oh yeah, it's got to be from that moment. So you got to find where they cross, and then I got to figure out what the heck is that? And then you might be led to figure out a log, because that's a rewrite. Remember, you can set this equal just to figure out for funsies what x must be, but then it won't be that. It'll be like on either side of it. So once you realize, oh, this is log, I'm going to do a log on both sides. Log base 2, log base 2, that's log base 2 of 5. That's some important number, but it's not the answer. It's a range of answers. So you figure out that decimal, which is like, let me think, 1.3 or something like that. Then I got to figure out, when is that bigger than 5? It would be the numbers that are bigger than that. And you can try things like, let's try 2. Oh, you're right. Let's say it's like 2.3 or something. Okay, so then let's say this is 3. And if I put in a 3, yeah, it's definitely bigger. So it works over here. I checked 3. All right. Okay, so don't forget, when you're doing greater than signs, those, or less than, those kind of go with number lines. Yes?
If you were to rewrite the exponentials within an equality, when you put it in a log, would you switch the sign?
That was a long sentence. Could you say that again?
So with the 2 to the x is greater than 8, if you rewrote that as a log,
If you rewrote that as a log,
it would have to be log base 2 over 8.
log base 2 of 8, and then there's an x, and then yeah, there would have to be a sign in there. You got a good point.
Would it have to switch with the original exponential?
Let's figure it out. Okay, how about this? Would you agree that that log base 2 of 8, that it would really be 2 to the third? So would it be just like 3 and x? So we got to figure out what sign should go in there. Think about it. X is bigger than 3 is the same as 3 is less than x. Do you agree we've got the right sign? So what's the moral of the story? I guess if the x is on the left side and the x switches to the right side, you'd have to switch signs. I think that's what's going on there. The x was on the left side. We switched the x to the right side, so we're going to have to switch the sign. I think that's what it is. We're not going to make you do that. What we'd make you do is figure out what it equals. Remember when I said you could say it's just equal for funsies? And you figure out, oh, x must be 3. But then 3 isn't the answer. Then you got to draw your line. Here's a 3. And then you go, okay, is it biggers or lesses? So I'm going to try the 4, put in a 4. It definitely works. It's the biggers. There we go. And I know there's no such thing as lesses, but just got carried away with my linguistic prowess. All right, we're going to get rid of this 10 by dividing by 10 on both sides. Did I divide by a negative? No. If I had, don't forget you'd do what? Switch the sign. Sorry, 15 tenths. You'd rewrite it. Log base 2 of 15 tenths is, here's the x. I don't want to say less than, I want to say equals. And then I'm just going to put it on a number line. And this is some nasty decimal. And then I find that nasty decimal, put it on the number line, and then I test things around it. And I see, what if I put in a 5? Numbers that are to the right of it. Well, that's going to be definitely bigger than 15. So it's the numbers to the right of whatever this number is. Okay, I'm not sure what that number is, though, so we'd have to figure out what that number is and then test intervals. So whenever you see greater thans or less thans, I've said this to kids before, and I don't know if I've ever said it to you. See how that kind of looks like the tip of a number line? You get that? Greater than signs, kind of like the tip on the end of a number line. Whenever you see those, think number lines. I should make a number line, because your answer is always like a range of numbers. Okay. All right. So we've gone, okay, this one, use your calculator only. I wonder what I'd do. No, don't graph both sides and see where they cross. You'd graph both sides and see where they intersect. All right. Your assignment is all of those, and I did a lot of them. All of those, and I already did like, well, at least 1.5 of them. And then these, graph of function. I think we could skip B. You don't have to skip B. You can do B. All right. And that's all I have for today.
Do you want us to do 9 too?
Oh, wait. Question? Yes.
Okay.
That's all I have for today.